Hey guys, today I will introduce you to differential equations. And I think the best way to explain this is just get into some examples. So say you have been given something like dy dx equals 2x for simplicity. What is differential equation? Basically, it's an equation that contains a function and its derivative or derivatives, so it could be more than one. So in this case, you are given dy dx, which is basically stands for the derivative of y with respect to x equals to x. Or also, the same differential equation could be written in the another way. So instead of dy dx, we could write just y prime equals to x. It's just the same, absolutely precisely the same differential equation, but written just using two different ways, using prime notation and using this dy dx notation, if you will. Now, how to solve differential equation and what does it mean to solve differential equation? So it's completely different from solving a normal algebraic equation. So when it comes down to solving algebraic equation, so basically we're looking for a number or an actual value or numbers or set of numbers or values, if you will, that work, that satisfy your algebraic equation. So when it comes to differential equation, so we're looking for a function, so or it could be a class, a set of functions that work for that equation, so basically that make your equation true. So this is different. How to practically solve the differential equations? So basically there is no one like technique way to solve all existing differential equations. So generally speaking, it depends on what type of equation you are given. So sometimes you might say this is called ordinary differential equations. Ordinary means that you have a derivative of a function with respect to one variable. So you have the function y with respect to x. Sometimes you are given multivariable functions and you might be given partial derivatives. So in this case, it's not going to be ordinary, it's going to be partial differential equations. Also, the order of this ordinary differential equation is going to be 1 because you have the first derivative. So your differential equation contains the first derivative, y prime. Sometimes you are given something like y double prime, let's say, plus y prime, let's say, minus x squared equals 0. So this equation is considered to be second order differential equation because the highest power of derivative that goes into your equation is 2, since you have y double prime, that means the second derivative. So, and obviously there is another technique and other ways of solving these types, this class of equation, if you like. It's also completely another story. Let's take a look at the basic types that I'm going to cover in this episode. So let's say you have been given something like this. Again, so this is the basic kind of differential equation, and we're going to find the general solution, as they say, for this equation. So basically it's going to be a family of functions, a bunch of functions, a set of functions, if you will, that work, that satisfy your equation. As a good rule of thumb, as a general idea, so this kind of equation could be solved by integrating the both sides of your equation. So what we're going to do, we're going to take the integral or antiderivative, if you will, from both sides, from left hand side and from right hand side of your equation. So go ahead, and I'm going to take the integral from both sides of this equation. So I'm going to rewrite it again. So dy dx equals 2x. And I'm going to integrate both sides. So I'm going to take this integral from both sides with respect to x dx. So recall that taking the integral and the derivative, it's the inverse operations of each other. So basically they untangle each other. So on the left side, you would be left with just y, your function, equals. And here all you do is just take the entire derivative of the integral of 2x. And since you are given 2 constant, you want to keep it. And since you have x and basically the power of 1, it's implied to be 1, it's understood to be 1. So all you do is use just power rule for integration. So all you do is just raise this power by 1. So 1 plus 1 becomes 2, and you divide it by 2. And you need to add this arbitrary constant of integration c, as I mentioned before, that gives you basically not one but a bunch, a family of functions that differ by this arbitrary constant c, if you will. You do this simplifying a little bit, so this 2 and 2, they cancel each other out, so this 2 eventually goes away, and you would be left with something like y equals, so you would be left on the right side x squared plus c, and that's gonna be your solution, your general solution, if you will, for this differential equation. And why it's called basically the general solution? Again, because you have not one function, you have this bunch, this family, this set or class of functions, if you will, that work for this equation. Sometimes you are asked to find the particular solution, but at this point you have to be given this kind of initial condition, if you will, something like y of an value equals another value, and it's completely different story, it's another whole video, and it's coming up. But at this point, this is going to be the solution for this equation. And if you will, you could check it out, and all you do is just take this function, namely x squared plus c, and you're going to substitute instead of y over here. So we're going to get, so x squared plus c, and all it says that this is the first derivative, so prime, and we're going to check, does it equal to 2x? So all we need to do is just take the derivative of this. So recall that x squared is just power of x, and all we need to do is just apply a power rule for differentiation. So x squared, the derivative of x squared, is all you do is just bring this constant in front. So it becomes 2x, and you reduce this power by 1. You take it, you knock it down by 1. So it becomes just 1, so I'm not going to write it explicitly. So since c is a constant, is an arbitrary constant, the derivative of the constant is just 0. So c goes away, it disappears. And as you see, so 2x is precisely equal to x. So we have this identity, so it's equal, left-hand side identically equal to the right-hand side. So that's totally true, absolutely true. And that means that this bunch of functions work for our differential equation. So this is your solution set. Alright, again I'm going to repeat myself. This is kind of a basic type, and if you come across to something like this, so if you're given just the first derivative on the left side, the first derivative, and you are given some function in terms of x or other variable, it could be t or whatever you are given, but just meaning one variable. So the general idea as a good rule of thumb, you need to integrate by both sides with respect to that given variable, the variable that you are given. And when you do integrate, do not forget to add this arbitrary constant of integration c, because eventually you are left with a bunch of functions that work, that satisfy for your differential equation. So if you are down to how to find the particular solution, again, this is a general solution to your differential equation, and if you're up to find the particular solution that satisfy the given initial condition, that's a separate video, the whole entire video, and it's coming up. Alright, huge thanks for watching and training your brain. I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below. Be sure to smash the subscribe button if you haven't, so you will not miss out my new videos. To differential cannot say differential. God help me.
Differential.
Today I will introduce you to differential. What is it? So what is a differential equation? So